Hello everyone, today we are going through some important questions of linear programming problem. First question, draw the graph of 5x plus 4y is equal to 40, x is equal to 4, y is equal to 5. From this second question, solve the following LPP graphically, maximize z is equal to 3x plus 5y, subject to the constraints 5x plus 4y less than or equal to 40, x less than or equal to 4, y less than or equal to 5, xy greater than or equal to 0. So given constraint, these are the given constraints and objective function is maximize z is equal to 3x plus 5. Here first of all we have to draw the graph, right? So this one x is equal to 4 and y is equal to 5 we can draw directly. It is the line x is equal to 4 and it is the line y is equal to 5. Next we have to draw the straight line 5x plus 4y is equal to 40, right? 5x plus 4y is equal to 40. When x is equal to 0, y is equal to 10. When y is equal to 0, x is equal to 8. Now plot the points 0, 10. See, it is the point 0, 10 and 8, 0. It is the point 8, 0. Join these points. Now it is the line 5x plus 4y is equal to 40 and constraint 5x plus 4y less than or equal to 40. And here the constraint it is y less than or equal to 5. X less than or equal to 4. Okay. Now we have to find the feasible region, right? So here x less than or equal to 4 means this side, right? Y less than or equal to 5 this side, right? And 5x plus 4y less than or equal to 40. It is the line 5x plus 4y is equal to 40. So less than or equal to 40, the region towards the origin, right? So here this side. So here common region is this one, right? Common region is, it is the feasible region. Okay, it is the feasible region. And what are the corner points? These are the corner points. Okay, so here we have to find maximize, right? No, here no need to consider this origin because here we have to find the maximize. So that is maximum value of z. Okay, so let's take these 3 points. Okay, corner points. Z is equal to 3x plus 5y. Okay. Here we have to find at which points the given function, that is z is maximum. So corner points, this one 4, 0. What is z? Put x is equal to 4, y is equal to 0. Z is equal to 3 into 4, 12. Okay. Next is, okay, what is this one? 0, 5. 0, 5. Z is equal to, substitute x is equal to 0, y is equal to 5, that is 25. Z is equal to 25. Next, what is this point? It is nothing but intersection of this y is equal to 5 and x is equal to 4. Right? That is, this point is nothing but 4, 5. Okay? 4, 5. Z is equal to 3 into 4, 12 plus 5 into 5, 25. That is 37. So here the maximum value of z is 37 at which point? At 4, 5, right? So here we can say maximum value of z is 37 at 4, 5. Maximum value of z is 37 at 4, 5. X is equal to 4, y is equal to 5. Minimize and maximize z is equal to 3x plus 9y subject to the constraints x plus 3y less than or equal to 60, x plus y greater than or equal to 10, x less than or equal to y, xy greater than or equal to 0. So first of all we have to draw the graph, right? So for the graph we have to consider each constraints x plus 3y is equal to 60. Okay, xy, when x is equal to 0, y is equal to 20, right? When y is equal to 0, x is equal to 60. Okay. So let's plot the point 0, 20. So it is the point 0, 20 and 60, 0. 60, 0. Then join these points. So it is the line x plus 3y is equal to 60. Constraint is x plus 3y less than or equal to 60. Okay. Then next constraint x plus y is equal to 10, greater than or equal to 10, x plus y is equal to 10, x, y, when x is equal to 0, y is equal to 10, when y is equal to 0, x is equal to 10. Plot the points 0, 10 and 10, 0. Join these points. So it is the line x plus y is equal to 10, the constraint x plus y greater than or equal to 10. Okay. After that, x less than or equal to y, that is x is equal to y. X is equal to y is nothing but it is the line passing through the origin, right? So it is the line x is equal to y. So here constraint is x less than or equal to y. Okay. So here, okay, now we have to find the feasible region, right? So first of all, let's consider this one, x plus y greater than or equal to 10. Therefore, here region is outside of this line, right? This side, okay, x plus y greater than or equal to 10. And x plus 3y less than or equal to 60, that is the region towards the origin, right? So this side, okay. After that, next x less than or equal to y means y greater than or equal to x. So here the region greater than, that is y greater than, right? Therefore, it towards y axis, okay. So this side. So what is the common region? See, it is the common region, okay. You just imagine, see, if you are confusing, you just shade the region for each constraint, okay. See here, x plus y greater than or equal to 10, this side, that is the region outside of this line, and x plus 3y less than or equal to 60, the region towards the origin, okay. And this line x less than or equal to y means y greater than or equal to x. That means here y greater, right? So here the region towards y axis, okay. So this side. So the common region is this one, okay. So how many points? Corner points? 4 corner points, right? That is, one is 0, 10, 0, 20. Then we have to find this point. It is the intersection of x is equal to y and x plus y is equal to 10. So here itself we can find x plus y is equal to 10. Here x is equal to y. Therefore, x plus x is equal to 10. 2x is equal to 10. X is equal to 5. X is equal to 5. Therefore, y is equal to 5. So it is the point 55. Okay, it is the point 55. Next, it is the point intersection of x plus 3y is equal to 60 and x is equal to y. Okay, that is x plus 3y is equal to 60. Substitute x is equal to y. So y plus 3y, because this line, right, that is x is equal to y. Okay, is equal to 60. 4y is equal to 60. That implies y is equal to 15. Right? Okay, so y is equal to 15. X is equal to y is equal to 15. X is equal to 15. Right? Because x is equal to y. So this point is nothing but 15, 15. Okay. Okay, these are the corner points. Now let's find the value of z, and we have to find at which points the given z objective function is maximum and minimum. Okay, so corner points, z is equal to 3x plus 9y. Okay, the corner points are 0, 10, 0, 10. Substitute x is equal to 0. Y is equal to 10, z is equal to 90. Okay. Next point is 5, 5. 5, 5, z is equal to, x is equal to 5, y is equal to 5. That is 15 plus 45 is equal to 60. Next point is 0, 20, z is equal to, x is equal to 0, y is equal to 20, that is 180. Right. Next point is 15, 15. 15 into 15, z is equal to 3 into 15, 45 plus 9 into 15, 15 into 9, 45, 13, right? So 135. That is equal to 180. Okay. So here, see. What is the minimum value? Minimum value of z is nothing but 60. Okay, minimum value of z is 60 at which point? At 5, 5. At this point. Okay, minimum value of Z is 60 at 5, and maximum value of Z is how much? 180 at 2 points, right? 0, 20 and 15, 15. Okay, is 180 at 0, 20 and 15, 15. Consider the linear programming problem. Maximize Z is equal to x plus y subject to 2x plus y minus 3 is greater than or equal to 0. X minus 2y plus 1 less than or equal to 0. Y less than or equal to 3. Xy greater than or equal to 0. Draw its feasible region. Find the corner points of the feasible region. Find the corner at which Z attains its maximum. See, same question. Okay. So here objective function is Z is equal to x plus y, and these are the constraints. Okay, so here first of all we have to find a feasible region. To find the feasible region we have to draw the graph, right? So for that let's consider these constraints. 2x plus y minus 3 is equal to 0. Xy, when x is equal to 0, what is y? Y is equal to 3. When y is equal to 0, x is equal to 3 by 2, right? So let's plot the points. 0, 3, 0, 3. That is the point. It is the point 0, 3 and 3 by 2, 0. Okay, 3 by 2 is nothing but that is 1 point something, right? So it's between 1 and 2. So somewhere here, let's take. Okay, so it is the point 3 by 2, 0. So join these points. So it is the line 2x plus y minus 3 is equal to 0, and the constraint 2x plus y minus 3 greater than or equal to 0. Okay. After that, next constraint. X minus 2y plus 1 is equal to 0. Xy, when x is equal to 0, y is equal to 1 by 2, right? When y is equal to 0, x is equal to minus 1, okay? So here 0, 1 by 2, see, it is 1 by 2, 0, 1 by 2, it is the point 0, 1 by 2, and minus 1, 0, it is the point minus 1, 0, join these points. So it is the line x minus 2y plus 1 is equal to 0, constraint x minus 2y plus 1 less than or equal to 0. Okay, and y less than or equal to 3. So here we have to draw y is equal to 3 in graph. That is y is equal to 3. It is the line y is equal to 3. And next we have to shade feasible region. Okay, so here 2x plus y minus 3 greater than or equal to 0. Therefore the region is outside of this line, so this side, right? Okay. Next, x minus 2y plus 1 less than or equal to 0. What is this line, right? So less than means this side, okay? This side, because it is less than. Or you can take, see, it is x less than or equal to 2y minus 1, okay? So here 2y is greater, right? So it should be towards y-axis, okay? Here y is greater, okay? So you just, if you want, you just take the values, put x is equal to 1. Here you will get, see here, what is greater? Y is greater, right? Therefore, x minus 2y plus 1 less than or equal to 0. Here we will get y is greater. Therefore, the region towards y-axis. Okay, region towards y-axis. Next is, see, this line. Here y is less than or equal to 3. Therefore, towards the origin, right? So this side. So the common region is this one. Okay, common region is this one because 2x plus y minus 3 greater than or equal to 0, this line. So outside of this line, and here it is towards y-axis. Okay, it is less than or equal to 0. If you are confusing, you just take this one, okay, or substitute the values. If you get y is greater, then the region towards y-axis. Okay, so here it towards y-axis. And y less than or equal to 0, therefore it towards the origin, okay, region towards the origin. Therefore common region is this one. So it is the feasible region, okay, and the feasible region contains the corner points. What are the points? One is 0, 3, and here this one, here it is the line intersection of y is equal to 3 and this one, right? So let's find y is equal to 3 and this line is x minus 2y plus 1 is equal to 0. Substitute y is equal to 3 here. So x minus 6 plus 1 is equal to 0. That is x minus 5 is equal to 0. So x is equal to 5. So it is the point 5, 3. Okay, x is equal to 5, y is equal to 3. Okay. So corner points 0, 3, 5, 3. Then this point. See, it is the intersection of these two lines, right? That is 2x plus y minus 3 is equal to 0 and this line, sorry, this line and this line, right? That is x minus 2y plus 1 is equal to 0. Okay. Now let's solve these two equations to get x and y values. So here, see, x is equal to, what is x value? What is x is equal to? That is 2y minus 1. Substitute this x is equal to 2y minus 1 in this equation. We will get 2 into 2y minus 1 plus y minus 3 is equal to 0. That is 4y minus 2 plus y minus 3 is equal to 0. That implies 4y plus y, 5y. 5y minus 5 is equal to 0. Take minus 5 right side. So 5y is equal to 5. That implies y is equal to 1. So when y is equal to 1, substitute y is equal to 1 here. So x is equal to 2 into 1, 2, 2 minus 1, 1. Therefore x is 1, y is 1. Okay. So it is the point 1, 1. Okay. So what are the corner points? 0, 3, 1, 1, 5, 3. Now, see, we have answered for two questions, right? Draw its feasible region. We have got the feasible region. And find the corner points of the feasible region. What are the corner points? 0, 3, 5, 3, 1, 1. Okay. Next is find the corner at which z attains its maximum. So at which point the given z is maximum, that we have to find. Okay. So corner points z is equal to x plus y. Okay. Corner points 0, 3. Substitute x is equal to 0, y is equal to 3, therefore z is equal to 3. Next is 1, 1, z is equal to 2, 1 plus 1, okay. Next 5, 3, z is equal to 8, 3 plus 5, 8. Okay, so here maximum value of z is 8, right? Therefore, the maximum value of z is, maximum value of z is 8 at which point? At 5, 3, right? At 5, 3. Solve the following linear programming problem graphically. Minimize z is equal to 200x plus 500y subject to x plus 2y greater than or equal to 10, 3x plus 4y less than or equal to 24, xy greater than or equal to 0. Here objective function is z is equal to 200x plus 500y. Constraints are x plus 2y greater than or equal to 10, 3x plus 4y less than or equal to 24, xy greater than or equal to 0. So here first of all we have to draw the graph. For that x plus 2y is equal to 10. xy, when x is equal to 0, y is equal to 5, right? When y is equal to 0, x is equal to 10. Plot the points 0, 5. When x is equal to 0, y is equal to 5. So 0, 5, it is the point 0, 5. And x is equal to 10, y is equal to 0. So it is the point 10, 0. Draw this line. Okay. So it is the line x plus 2y is equal to 10. Constraint is x plus 2y greater than or equal to 10. Okay. Next is, next constraint 3x plus 4y less than or equal to 24. So to find the values of x and y, take 3x plus 4y is equal to 24. xy, when x is equal to 0, y is equal to 6, right? Okay. So when y is equal to 0, x is equal to 8. So 0, 6, 0, 6, it is the point 0, 6, and 8, 0, it is the point 8, 0. Join these points. So it is the line 3x plus 4y is equal to 24. Constraint is 3x plus 4y less than or equal to 24. Okay, now let's find the feasible region. Feasible region, see here, x plus 2y greater than or equal to 10. It is the line, right? So it is the line. So the region is outside of this line. Okay, outside of this line. And 3x plus 4y less than or equal to 24. Which line? This line, right? So less than. So down. Okay. So here, see, what is the common region? It is the common region, right? It is the common region. Okay. That is, it is the feasible region. So here, how many corner points? 3 corner points. Now let's find at which point the given this z is minimum. Okay. So what are the points? 0, 5, 0, 6, and this point is the intersection of these two lines. Let's find x plus 2y is equal to 10, 3x plus 4y is equal to 24. Okay, from this we can write x is equal to 10 minus 2y. Substitute, they say x is equal to here. So 3 into 10 minus 2y plus 4y is equal to 24. 30 minus 6y plus 4y is equal to 24. That is 30 minus 2y is equal to 24. This implies, take this 24 here. So 6 is equal to 2y. That implies y is equal to 3. So y is equal to 3. Substitute y is equal to 3 here. Therefore x is equal to 10 minus 6, 4. Okay. So this point is 4, 3. Point is 4, 3. Okay. So what are the corner points? 0, 5, 0, 6 and 4, 3. Now let's find at which point z is minimum. Corner points. Z is equal to 200x plus 500y. 0, 5. At 0, 5 z is equal to 2500, right? 500 into 5. At 0, 6 z is equal to 3000, right? Next, at the point 4, 3 z is equal to 200 into 4, 800 plus 1500, that is equal to 2300. Okay. So which is minimum? The z is minimum value of z is 2300. At which point? At 4, 3. Right? Therefore, here we can say minimum value of z is 2300 at 4, 3.